Among countless stars, there are places where even light fails. A place whose name raises 1,000 questions in our minds. And a place where all the laws of physics fail. Yes, I'm talking about black holes. Today, we're going to talk about such a mission. A journey that could take humanity to the very doorstep of a black hole. So, fasten your seatbelts, because we're about to embark on a journey from which there may be no return. This is Journey to a Black Hole. One small step, one giant leap. So, friends, when we talk about reaching a black hole, the first question that comes to mind is how? Black holes are so far away that reaching there is a daunting challenge in itself. Even our fastest rockets today would take millions of years to reach there. So, is this mission just a dream? Absolutely not. Scientists are working on a solution to this too. The solution is a small, yet powerful spacecraft called a nanocraft. You might be thinking, nano means very small. Yes, this spacecraft will be so small that it will weigh only around 1 gram. Imagine a spacecraft the weight of a paperclip. Behold the wonder of technology in this tiny package. It will be equipped with tiny sensors, a high-resolution camera, communication devices, and a small power source, all contained on a single chip. But how will such a tiny spacecraft travel such long distances? It doesn't even have enough space to store fuel for its rocket engine. This is the most revolutionary part of this mission. This nanocraft will be propelled by the pressure of light. Yes, you heard that right. When light strikes a surface, it creates a very slight push. Even this small push can do wonders. Attached to this nanocraft will be a very large and thin sheet called a light sail. Imagine a kite as big as a football field, yet 1,000 times less thick than a hair. This light sail will be made of a material that is extremely light, strong, and highly reflective. Now, where will the wind come from to fly this kite? The wind will come from the ground. Scientists will build a joint array of thousands of powerful layers on the ground, perhaps in a desert. All these layers will combine to create an extremely powerful beam and focus it on this light sail. As soon as this mega laser beam hits the light sail, millions of its photons will transfer their momentum to the light sail. In simple terms, this burst of light will give this light sail a tremendous push forward, and the push is no small one. During this laser fire of just a few minutes, the lasers will be so powerful that they will accelerate this nanocraft to 1/3 the speed of light. This is such a high speed that our chemical rockets seem like children in comparison. So the plan is ready. A small nanocraft, a large light sail, and a powerful push from the ground. This is our ticket to a black hole. But why do we want to go there? Such lengthy preparations. What is this long wait for? Why do we have to go there? The attraction of a black hole. This question is very reasonable. Why should we spend eternity and infinite resources on a mission whose outcome we may not even live to see? The answer lies in humanity's deepest curiosity. How does the universe work, and what are its limits? Black holes could be the key to answering all these questions. The first reason, the ultimate test of Einstein's theories. Albert Einstein formulated his general theory of relativity more than 100 years ago. We've tested this theory everywhere in the solar system around stars, and it's proven correct every time. But a black hole is a place where gravity is so extreme, so intense, that it will be the true test of Einstein's theory. At the far end of a black hole, near the event horizon, Space-time bends so much that even our imagination fails. Will Einstein's equations work there? Or will we need a new, better theory? This mission will provide a direct answer. The second reason is the confluence of two worlds, quantum and gravity. There are two major pillars in the world of physics. One is general relativity, which works on the large scale of planets, stars, and galaxies, and the other is quantum mechanics, which explains the world of atoms and particles on the much smaller scale. The problem is that these two theories don't talk to each other. They contradict each other. Scientists have been searching for a theory of everything for centuries that can unite them. A black hole is a place where these two worlds collide. A black hole has a tremendous mass, but at its center, called the singularity, all this mass is contained within an infinitely small point. By understanding this point, we may perhaps get closer to a theory of everything. The third reason is the mystery of the information paradox. The great scientist Stephen Hawking raised a profound question. What happens to the information when something falls into a black hole? A fundamental law of physics is that information can never be destroyed. But a black hole swallows everything. So, does information disappear forever? This is called the black hole information paradox. Our nanocraft will pass near the edge of a black hole and observe the faint radiation emanating from it.